Okay. So do you have any questions, comments? We have a midterm tonight, right? No. It's on the syllabus, right? No. No. I'll post that tomorrow. Yeah. Tomorrow morning when you wake up. The midterm exam will be available, and it will be due when?
At the end of the term?
End of term?
No. Yeah, it will be on 18th. Yeah.
Is it multiple choice?
No. It's much more than that. But similar to the homework, the problem. We probably no new questions. Similar.
The 19th is holiday.
Hmm?
The 19th is a holiday.
Mm-hmm. Also, on 19th, yeah, so maybe not the 18th, maybe, just tell me a date.
21st. 21st sounds good.
21st is which day?
Wednesday.
Oh, cool.
March 5th.
No, sorry. You could have tried that. I'll get my new mouse here. Oh, no. Yeah, let me modify this. So it'll be the 21st? 21st, yeah, 21st. You said that, so okay.
I think they just put one thing.
21st, yeah.
Of March.
No.
No, it's just, sorry.
Yeah.
I'm in the wrong month too.
Okay, good.
Do you have a certain amount of hours to do it, or do you get to open it, work on it, close it, come back to it?
I don't know, so
How many questions?
let's
You want us to pass?
how many questions? I don't know.
Huh?
So there are two choices. One choice is like the homework. So maybe you can download a copy, then when we finish you upload the file.
That sounds good.
The other one is similar to the quiz. So you have a time limit of maybe a couple of hours to work on the problems and then submit through.
I prefer no time limit if there's a choice.
Yeah, like the homework.
Okay.
Unless you're going to do multiple choice for the time.
I know. Actually, the multiple choice can be as difficult as the problem solving because, yeah, I give you problem solving questions and the answer will be a multiple choice. But anyway, I would be nice. It will be similar to the homework here.
Oh, great.
But you have to work on the midterm exam independently. It's a test. So. But if you have any clarifying questions, of course you can ask me. Okay. Any other complaints? And we'll cover chapter 5 and 6. It's a lot of material. And chapter 5, the quiz will be difficult. And that's why chapter 6, the quiz is free. Actually, I'm not sure whether you...
Yeah, so
Yeah.
You making this?
You already... Yeah. So, yeah, that's it. So chapter 6 is everyone. So let's say get only 10 points in the quiz 5, so we're still okay. And also today after class, the MA students will stay for a while, take a look at a different topic. Okay. So we'll take a look at forecasting. So again, I strongly, you already in this class today, so that's good. But otherwise, make sure you watch the video because I have to go through all those calculations through the Excel QM. So I will try to capture everything on the video, so just in case you need to. And so basically chapter 5 is about forecasting. And there are many different ways we can do the forecasting. There are many different ways. But the focus of this chapter is about quantitative. So how to use the quantitative methods and to predict and forecast the future value based on the historical value. And there are many different models. You see there are many different models. So we have the qualitative models. So when we take the quiz for chapter 5, you may have this slide in front of you here. So qualitative models and time series of models and the causal methods. You see the causal methods we discussed before. What is the causal methods? Cause and effect. So we have one dependent variable, one independent variable. And so it's based on the regression analysis or multiple regression analysis. And the time series model based on the several techniques, because if you take a look at one particular data series, there are many different components. The seasonal factor, like the fourth quarter, is better for most of the companies, right? The fourth quarter, because the Christmas sales. And usually January is a very slow quarter, January. So how to take care of that, the seasonal effect. And the overall trend, right? Overall trend, you see the overall trend. So in this chapter, we'll take a look at basically how to decompose the data series into the seasonal factor, the trend, and the noise, the random variation. And so time series methods and causal methods are quantitative models. And also have qualitative models. And especially if they don't have any historical data. So let's say they just started, Apple just launched the iPad 10 years ago, right? Or maybe 9 years ago. There's no historical data. No data, right? So if that's the case, it has to basically, it depends on the qualitative analysis. And in terms of the qualitative analysis, we have several methods. But most of the methods, depending on the executive or the experts' view, the experts' view. So we have a Delphi method, the jury of executive opinion. So basically, you collect the opinions from a group of experts. People with expertise, high-level managers. And Salesforce, basically, each sales audit allows individual salesperson estimates, and then put all the data together. Consumer survey, to identify consumers' taste preference, and spending plan for the next couple of years.
Kind of when I started all those like grocery stores,
Exactly.
codes and stuff like that to see what you buy and.
Exactly. Or sometimes it's just do a survey for the existing established customers. Okay. Well, our focus is on the quantitative data. So we'll first take a look at the time series models. The time series models. So the idea is the future value is based on what happened in the past. In other words, if we study the historical data, we'll be able to identify the pattern and then predict the future value. So it's based on historical data. And of course, in this case, we ignore all other factors: economic condition, competition, selling price. We only focus on the data components, nothing else. And for a particular data series, like the total sales for a company over the years, and there are 4 possible components. the trend, seasonal factor, cyclical, and the randomness. So that's the T, the S, C is for cyclical, and R is for randomness. So I'm not sure whether it's clear, but in this case you can see so series 1, you see there's only random variation. There's only random variation, not much. And then how about the series 2, this data set series? You see the seasonality. So usually maybe during the Christmas time, the fourth quarter, the sales is strong. So that's the seasonality. And series 3, you can see there's an overall trend. The trend is upward slope. So, for example, the total national income data series. So over time, it increases. We have more population, and also the production increases over time. So the overall trend plus what? The random variation. And the last one, we have everything, right? We have the trend, we have the seasonality. You see the seasonality, and also the randomness. And this is about the cyclical effect. Now, what is a cycle? The cycle basically is it's just like a business cycle. Every 10 years, for example, it repeats. And if you take a look at the U.S. economy for the last business cycle, hold on. Where is it? What is the agency? Hold on. Hold on. How can I forget that? Hold on. Cycles. MBER. MBER.org. Cycles. Business cycles. So this agency determines the business cycle for the U.S. economy. A complete cycle basically is 2 parts, right? So basically, it's if you take a look at our this may be a complete cycle from peak point to another peak point. So it comes down, it goes up. So this is one cycle.
The U.S. economy is done by quarters as well, though, right?
Yeah. So again, the GDP, when they report GDP, it's a quarter data. But the quarter data, again, you can see the seasonalities because during Christmas time, just people have more
Quarterly
activities.
would be the cycle, right?
No, this is a seasonality. And cycles, well, if you look at what is cycle, I have basically those are the cycles. So 2 parts, yeah, contraction from the peak to the bottom, then from the bottom to the peak, expansion. That's a complete cycle. And so I have some data here. See, from 1945 to 2009, we have 11 cycles. 11 cycles. And on average, the contraction 11.1 is contraction. The 11.1 contraction is about 11.1 months. And how about expansion? Is 58.4 months. In other words, 1 year contraction followed by how many is 5 years of expansion. So on average, the one particular cycle is 6 years. So the last cycle we had is what you can see. That's the December. I think that's the starting. That's the peak here. Hold on. Yes, that's the starting point. Peak here. And 2007 December. Remember the housing bubble?
Oh, yeah.
And all the way to June of 2029.
18 months.
So 17, 18 months. 17, 18 months. it's a relatively short cycle. But yeah. So now, are we going to have another cycle?
That was a
Nobody
contraction,
knows.
wasn't it, from peak to trough?
Yeah.
Oh, so you figure, well, 5 years from there is what we should have here.
But now, I mean, it's more than 5 years already, the expansion. It's up to today, right? So, I mean, when is the next a contraction? We don't know, right? No. That's a unique thing about business cycle. Nobody knows.
Is it like when something
It is unpredictable.
huge happens or something that they start it over?
So it's unpredictable. Nobody knows. Nobody knows. Nobody knows. So actually, we should go home, right? If we cannot predict the business cycle. Okay. So that's the cycle. So in terms of the timer series model, you can see different components. So we have different ways to decompose the data into the trend, the seasonality, cyclical, and the randomness. And so if you use any type of model, you predict the future value. So is this a good prediction? What is the standard, right? And what is the criteria? And we use, it's called mean absolute deviation, and we're being on the quiz. Yeah, and we're on the quiz, make sure you circle this mean absolute deviation. Now, what is mean absolute deviation? The forecasting error. You add them together. So for each data point, you have a forecasting error. Then you add them together. Now, what is forecasting error? That's so for example, you are predicting next year's stock market index for the S&P 500. So you generate one number according to your model. Let's say that's 2,000. But the actual number next year is 2,200. So now what's the forecasting error? The actual number minus what? The predicted number. That's the forecast error. So for each year, if you predict 5 years, so there's five forecasting errors, right? Forecasting errors. So you take the absolute value, each one of them, then add them together. So we have this is a naive forecasting. Okay, sorry. And this is a naive forecasting. What is naive forecasting? Basically, the story is very simple. So this is actual number for sales. Yeah, sales for a company. So the forecast sales. So this the projection for February is what? The actual number in January. So the forecasting for March is the actual number in February. So this is it's called a naive forecasting. So basically, the prediction for the current month is what happened in the previous months. The actual number in the previous months. So now, if that's the case, well, except the first one, we can do nothing, right? We needed the data from the previous year. We don't, so that's fine. But given, and also for the November, we have the prediction, but we don't have the actual number, so that's fine. So now we only have what, eight data points?
9.
No, how do you know 9? Oh yeah, that's 9. 9 data points. Yeah, 9 data points. So you see the forecasting error, that's the difference between the actual number and the predicted number. You take absolute value.
And they don't do negatives, so whatever you do different. It's like
Exactly.
the first one, it comes up, should be -10 if you do.
Yeah, it's just, that's why I take absolute value.
Absolute.
There are two ways you can square. We also have a mean square error method. But mean absolute deviation, MAD, yeah, that's more, it's more than enough. Add all of them together divided by 8, so divided by 9. So that's the mean absolute deviation. Okay. And they also have, you can see other methods. You can actually square. You can get rid of the negative by either take the absolute value, or you can just square. Okay. So that's mean square error. But in this class, we stay with MAD, mean absolute deviation. So we'll take a look at forecasting the random variation. So there's no trend. For now, there's no trend. No seasonality. No seasonality. Only random variation. So if you look at data, there's some random variation. Then how to forecast the future value based on the previous. So we use basically it's called moving average, or weighted moving average, or exponential smoothing. Moving average is we can have basically the idea of moving average is we take the average of the n data values. So for example, 3 weeks data. So if we use the moving average, it tends to smooth out the fluctuation, And so the moving average is sum of the demands in previous n periods. Let's say 3 weeks. So you add the 3 weeks number together divided by 3. Then you move on to the next week. But when you compute the next week's data, you will also include what? Next week and also the week before next week and the week before the previous week. So 3 data points. And I'll show you the number. And I think this example is very clear. So if we have the data from January to December, then you're asked to forecast January next year's data. So if we use, it's called 3 months moving average. So you need a 3 months data, right? 3 months data. So in other words, we can only start from what? April. Because in April, we have what? 3 previous weeks, 3 previous months of data. So the 3 months moving average for April is what? January, February plus March number divided by 3. Okay, so that's 11.67. Then, okay, so we're done with April. How about May? We'll use which month's data? May we will use February, March, and April. Good. How about this January?
October, November, December.
October, November, December. That's all. So that we take averages of 3 months, but it's a moving average. It's a moving average.
So is that so that you don't overestimate, I guess?
No, basically you smooth out the fluctuation. Smooth out the fluctuation, because for some weeks the data may be for a particular week it might be high, but if you take average, you always smooth out the fluctuation. And sometimes we may also use weighted. If you believe. So in this case, we have, remember we have the moving average is March, February, January, when we compute the moving average for April. But if you believe the most recent months has the biggest impact, then again you can assign weight. So let's say you assign for March, assign weight of 2. And the previous two months, you assign weight 1 each. Then we can compute weighted average. So for example, in this particular example, so if the last month, the most recent month, the weight is 3. And 2 months ago, it's 2. And 3 months ago, 1. That's a weight. So the last month has the most weight in. And 3 months ago has the least weight. Now, the denominator is what? Not 3. It's 6, because the total weight is 12. So if we calculate, if we calculate the same data set, if we calculate the weighted moving average, then if that's the case, we will use 3 times 13. 13 is the most recent month. 2 times 12, and 1 times 10. You divide it by 6. That's the weighted average. Now, whether you should use which method is better, it depends on what the method, the mean absolute deviation. So we can compare the mean absolute deviation. So the approach with the smallest mean absolute deviation probably should be selected. It's just like if you run a regression model, it depends how good is the model. It depends on the adjusted R-square, right? Adjusted R-square. So you want to select a model with the smallest adjusted R-square. So we'll take a look at some examples here, and also you can use Excel QM to do the questions. I have some hold on. Documents. Oh boy.
What'd you get the divided by 6?
Because the total weights is 3, 2, 1, that's 6.
Yeah, it goes up and divided by something.
So that's 6 here. So that's
Right.
6. Oh. What happened to my file? Oh, tonight. Did you see tonight? Yes. So we have, I believe if you look at the homework assignment, we have a question for, you have the book? Yes. Chapter 5, 17. Question 17. So we have the data for, oh, hold on. Yeah, this is the data, yeah, this is the data. This is the data. So that's for how many years? 11 months, 11 years, 11 years. And this is the demand, yeah, the demand. So those are the actual number. So the question asks you to develop a 3-year moving average. Then estimate demand again with a weighted moving average in which sales in the most years are given a weight of 2, and sales in the other 2 years are each given a weight of 1. Which method is better? So if that's the case, we needed to compute the moving average. So what to do? You take what? This one should be equal to
3 times 4.
No, if it's not, the first requirement is not a weighted moving average.
Oh, okay.
So you should do equal to the sum of, yeah,
Yes.
divided by 3. Oh, what happened?
Didn't have some in there before.
Oh, 4. How come? Sorry. Oh, that should be the sum, yeah. And then we can put a formula, right? And actually, if you are asked to predict the December's the 12 CS data, we can do it, right? We can do it. Yes. If you are asked to predict the 12, so you can just put a formula. And how about a weighted average? It will be a little bit more troublesome, yeah? It will be equal to what? 2 times what? B4? Yes? That's a weight, the most recent year, right? Plus what? 1 times B3? Yes. Plus 1 times B2. Divided by what? Divided by 6. Divided by 6. Oh no, divided by 4. Am I right?
4.
The total weights are 4, yeah? 2, 1, 1. 2, 1, 1, 4. So if I put a formula, it will be.
4.
And then you are also asked to compute the mean absolute deviation. How to do that? You see that this are the forecasted value, yeah? This is the actual value. So this number minus this number will be the mean absolute deviation, right? For the approach. This is the first, just the moving average. And for the weighted moving average, so those are the forecasted number. And again, we can compute the mean absolute deviation. Okay, good. Yes, but actually, the software, the software, this one. Oh no, not this one. Which one is this one? Enable, yeah? Okay. The software allow you to compute the weighted average with a few clicks. Let's take a look. So you go to Excel QM, and then what's next? Where to go? By chapters. Chapter 4 or chapter 5. Moving average. So the question, are we interested in title? No. We don't care, right? So, but do we have the number of past periods? How many data values do we have if you look at the question? Do we have 11 years of data? So you think you can increase this to 11? Yes. And the number of periods to average? If it's 1, it's naive, right? Remember?
Yeah.
So it's 3 years.
We have 3 years. So if you take a 5-year average, we have to use 5. It's 3 years. Okay. But if you want to see the graph, that would be fine too. So ready? So you select 11 periods. Yes. You select 3. The number of periods to average is 3. You click OK. So all you need to import is what? The demand. The demand. And remember, I have a demand somewhere, yeah? Hold on. 5. Where's 5, 7? I have this data. Yes?
Yeah.
Copy and paste. 517. No. Okay, where's the worksheet? No.
5 times 7.
Oh, this one. Then what? You copy and paste You see everything comes out. So this column is the forecast one, yeah? Forecast. Bad. Is that clear? Oh. Okay. So you can see those numbers are the projected values. Yes, the yellow one. And also, you see the next period, that's for period of what? 12, right? That's a prediction for year 12. Also, it's here. So you want to ask, okay, what is the mean absolute deviation for this one? And actually, it calculates the mean absolute deviation. This is the mean absolute deviation. Good? Yes? Okay.
What, the 2.5?
Yeah, yeah. That's the mean absolute deviation. There's no need. And also, the question also asks you to develop a weighted moving average. So that's so in this case we need to assign the weights 211. Remember 211. So what you can do is we can. So we're done with this one. Yeah, I'm going to delete this file. Oh, not the name. Just delete it. Okay. Then we can, okay, 517. Then I go back to what? QM, chapter by chapters. You see the weighted moving average? So number of past data periods, we have 11. And the number of periods to average, 3. Yes? And you can graph it if you want. Ready? And then we can import those values. But again, I'm going to cheat. I'm going to copy and paste the data I did this afternoon. Oh, hold on. Is this right? Yeah.
Yeah.
And then how are the weights? See, one period ago, we assigned weight of what? According to the question. Most recent year, gave a weight to, yeah? Yes? 2 years ago, you gave a weight of what? 1. And this column are the projected values. And where's the mean absolute deviation? This one. And you can see probably this one is better because the mean absolute deviation is smaller. Yeah, it's smaller. And this is the projection for next period. For year 12. Okay. Good? So that's the moving average. That's moving average. Okay. And do we have other one? 517. Okay. So the next approach is exponential smoothing. So the idea is the new forecast. So again, we're trying to predict the future value. So the idea is the new forecast is equal to what? Last year's forecast plus the alpha times the last period's actual demand minus the last period's forecast. In other words, this is what the forecasting error. Yeah, that's the forecasting error for the last period. So the new forecast is what? Last year's forecast plus alpha times the forecasting error. And alpha takes a value between 0 and 1, right? And if alpha is equal to 0, so the new forecast, that's a naive, right? New forecast basically is what? Last period's forecast. last year's forecast. So that's the formula, right? That's the formula. So the forecast for t plus 1 is equal to what? The forecast for time t, right? So the last period. Plus alpha, the actual number, the forecast error for the last period. So the idea is simple, right? The new prediction is the old estimate, the older estimate, plus some fraction of the error, the forecast error in the last period. So I have one example here. So the February's demand for certain model car is predicted to be 142. The actual number is 143. That's for February. So now what is the forecasting for March? For March, it should be what? According to the exponential smoothing, should it be the forecast for last month, which is February, 142, right? 142. Yeah. Plus what? 0.2. Well, if we select alpha as 0.2, the forecast error for February, because for February the predicted value is 142, the actual number is 153. So we have the forecast for March is 144.2. Then the actual number for March is 136. So what's the predicted value for April? Well, April again is what based on March's prediction plus 0.2 times the forecast error in March. The actual number is 136. The predicted value is 144.2. So that's the exponential smoothing. But again, which value of the alpha is the best for the model to predict the future value? You may have to assign several different alpha values, and you will you will select one with the smallest mean absolute deviation. The smallest mean absolute deviation. So this is the two models. So you can see we have quarters here, 1 all the way to 9. So that's more than 2-year data. So we have the actual number and also the prediction for quarter 1. So once we have those numbers, you will be able to finish the rest of the data. So for example, the prediction for second quarter, it should be equal to what? The prediction for the first quarter, yes? Plus what? The forecast error, 180 minus 170. Good?
So why do they have the two different alphas?
Pardon?
Why is there two different alphas?
Oh yeah. I mean, they're trying to use 10% or 50%. But again, which one is better? We need to take a look at the mean absolute deviation. And you can see the mean absolute deviation for the if alpha is 0.1 is 10, and for 50 is 12.33. And we can also use so let's take a look at the homework question. I believe is which one? 19? No. 17, 22, yeah? The car sales. So I have those car sales value. I think I typed it in 5. Only for five periods, 5 years. So what I'm trying to do is I'm trying to project what is the 6 years number. What is 6 years number? By using the exponential smoothing. And in this case, we're assuming the alpha is 0.3. So develop a forecast for years 2 through 6. And also we know for year 1, the sales was 410. That's the projection, right? Projection. So this is the actual number, yeah. And this is what the prediction, you know, 410. Am I right? That's fine. So how about for period 2? What's the formula? It should be the first year's C2. Yes, C2. Plus the alpha is 0.3, right? 0.3 times what? Times the forecasting error. What's the forecasting error for period 1? B2 minus C2. So once we're done with this, we can put a formula. And the projection for period 6 is 521 or 522. But you can also use, hold on. So you can write the formula, it's not that difficult. Or you can use the Excel template, exponential smoothing. So it asks you what? The number of past periods of data. How many data values do we have? 5. So you put a 5 here. And click OK. So we needed to put alpha here. Yes. What's our alpha? 0.3. And also the demand. Where's my 522? Oh boy, hold on. Which is this here? But don't forget, what's the projection for the first period according to the question? We have to have that number, right? That's 410, right? According to the question. So the nice thing about this is it calculates what? The mean absolute deviation for you, right? So you don't have to. And also, is this the same number we have? Yeah. Exactly the same number. So this number is the projection for the next period. Good. Okay. Any questions, comments for the moving average and exponential smoothing? Okay. Any questions, comments, or complaints? Okay. This is pretty straightforward, right? It's better than the probability. Remember, the probability is independence.
Yeah.
But you may see some of them in a midterm test. Mutually exclusive and not mutually exclusive. You draw a white ball from a bucket of. You hear those kind of questions. Yeah, I know. It's good.
That's good.
But this is very straightforward. I mean, given technique. But it's very useful technique. Okay. All right. Let's move on. So now we discussed about moving average, weighted moving average, exponential smoothing. But the data doesn't have any trend or seasonality. So how to adjust for if there's a trend if there's seasonal variation. So it'll be probably more complicated. For the trend projection, actually, it's pretty easy. If the data has a trend, what is a trend? It basically, you look at data, it increases over time, or it decreases over time. Then it's very easy for us because we can just use regression model to take care of it. And in this, remember what is a regression model? Y is equal to
B0.
A plus bx, yeah? Or equal to b, remember b0 plus b1x?
Right.
But in this particular case, the x is what? Not is the time value. So let's take a look at one example. So in other words, if you draw the line, the x variable here is the time period, the number of years. That's the time period. Okay. So I have this example, I believe. Hold on. That's a very basic, right? But if for the trend projections, x is the time period, 1, 2, 3, 4, 5. But if sometimes the question will tell you starting from 1998, 1999, so you have to replace that 1998 with what? Year 1. So 1992 will be year 2, right? You cannot just use 1998. It probably will not give you very accurate projection. So you replace the first year with 1, then 2, 3. So the idea is, so once we use, based on historical data, so we'll estimate those coefficients. Once we have those coefficients, and again we can, so let's say we have 7 years data. So we develop this equation. Then for the 8th year we can make a projection, which is all we need to replace this x value with 8, plug into the equation. For the 9th year we can do the same thing. And I believe we have I added one question this afternoon, yeah, if you notice. Okay, but anyway, the homework has 5 questions. The third one is 26. Use the trend projection method. Develop a forecasting model for the sales of the AC, see question 522. So based on 522. 522, remember, do we have the data? That's 522, we have the data, right? We have the data.
Yes.
What you need to do is, so those are the actual value, yeah? Or those are the numbers, 4 to 50. So that's the demand, for example. Or that's the Y, yes, that's a Y. And how about X? Period 1 is what? 1 year. Period 2 is 2 years, right? And then we can remember how to run a regression analysis. We can go to where? Data? Yes?
Yes.
Data analysis. Regression. So import a Y range. So I put import a Y range. And import X range. Labels.
Yes.
And that's the model. This is the model, right? Yeah. So that's the intercept. So y, basically y is equal to what? This is the intercept, and this is what? The slope, right? The slope. So the equation we're trying to develop is y is equal to 421.2 plus what?
33.6 x.
Times x, yeah, times x. Good. So you can just learn a regression, but use time as an independent variable. Okay. And but unfortunately, actually, this one also provides a tool for regression trend analysis. So how many data do we have? Data points? 4, yeah? No, 5. Question 22, we have 5. So where should you go? You go to by chapters, chapter 5, trend regression. This one, okay. 5. Then click graph, for example, click OK. So we can copy and paste the the data from 522. The demand for 5 years. Oh, now where is which one is the? Oh, this is the one, yeah. So you can copy into here, but not enough. Not enough. You have to assign the x value. So if it's 1998 is the first year, so that's 1, followed by 2, 3, 4, 5, and the projected value is 622.8. That's for year 6 data. Right. So are those numbers the same as our regression model?
Yeah.
It's the same, yeah. It's the same. Good. That's pretty easy, right? That's pretty easy. So basically, you run a regression model. Yeah. And then you can basically generate the trend. Okay, so there are too many files open. I'm trying to delete some. Confuses me. Hold on. Delete. Delete. What is it? Delete. This is what we did. Yeah.
So, just for the homework purposes, we're not given that formula, we're just going to do it in the trend projection, just copy and paste this data.
Yeah, and also the important thing is you have software to do the question, but if you just copy and paste everything into the Microsoft Word, but sometimes the question has many different parts. So it would be nice if you can indicate, say, okay, so you copy and this into Microsoft Word. And then after that, it would be nice, hold on, if you can, did you find the Microsoft Word? So you copy and paste, yeah, okay, you can paste the image file, yes. So you can do whatever manipulation, yes. Then you will say, okay, for part A, the answer is the equation y is equal to whatever plus whatever times x, for example. Yeah. So you need to specify. Remember when you are at elementary school, you have to circle the final answer? Yes. Use color pencil. Circle, yeah. So it would be nice if you can, otherwise I have to look around. And if I really cannot find, I have to deduct the points. Like the previous homework assignment, the trees. The trees have so many different parts. You just throw a tree,
Regression.
give me the tree. I cannot tell sometimes what is the final result. Okay, so, all right, good. Okay, now seasonal variation. So sometimes the data is has a seasonal pattern. So obviously, if we're trying to project the fourth quarter data, for example, we may have to assign more weight, right? For the first quarter data, we may have assigned lower weight. So we need to develop a seasonal index. So the seasonal index basically tells us how a particular season, of how a particular quarter, a particular month, compares with an average month, average quarter. So let's say if the average quarter, the 4 quarters in a year, right? If the average quarter, the average sales is 250. But for fourth quarter, the sales is 300. And for the first quarter, it's 150. And it's always the case. The fourth quarter has a high number. And the fourth quarter has a high number, and the first quarter has a low number. So if that's the case, we have to make some adjustment. Or we can take advantage of the information when we make prediction for the fourth quarter of next year, right? So we need to develop a seasonal index. So that's we can compare the particular quarter we're interested in, and also the average quarterly data. So if the index is equal to 1, so basically for this particular quarter, it's the same as the average quarter. If it's greater than 1, so that means the business sales are strong, right? Better for that particular quarter. If it's less than 1, season is lower than average. Slow, right? Slow. So based on this, based on the seasonal index, actually we can deseasonalize the data. Now what is deseasonalized data? So the data is adjusted by, we get rid of the season. So the deseasonalized data is created by dividing each observation by the seasonal index. See, the key here is to develop the seasonal index. This is very similar to if you do a survey. If I do a survey, so basically according to our sample calculation, we survey most of the people in Hawaii or Oahu. But if our total sample size needed is 6,000. But Hawaii has 900,000 people. Big Island, 190,000. And Maui is 160. So proportionally, those islands, Kauai 72. So we relatively get a very small sample. Hawaii, Oahu made 4,400 sample size. Kauai may only have 350. But if we want to know more about Kauai, sometimes we have to what? Oversample Kauai. Otherwise, so for example, if we want to know the food preference by different ethnicities, different gender, in different communities, and then if you create a table for Kauai, only 350 surveys, the data points are not sufficient. So we have to oversample Kauai, say 1,000. But when we compute the final number, we have to make an adjustment. Now what is that adjustment? Because Kauai is oversampled. Because in the total population, Kauai only have 72 out of 1.4 million. But the sample is much more than that. So we have to make some adjustment. So similar to deseasonalized data. So basically in this case, we can create a seasonal index. And then by using this seasonal index, we can deseasonalize the data. We're assuming that this is not a fourth quarter. We treat every quarter as a regular quarter. No seasonal factor. And once the deseasonalized data, so once we have the deseasonalized data, then the rest is easy. We can still use the trend projection. So we can project the future 4 quarters of deseasonalized data. So once we have the projection, and again we have the seasonal index, we can create the we can basically once we have the projection, we can create the seasonal data. And I have some examples here. So again, this is a seasonal data with no trend. I assume there's no trend, only seasonal data. So we divide the average value for each season. Now what's season here? Each month, if we're interested in months, a quarter. So we divide the value of each quarter by the average of all data, So we have the sales data for the past 2 years for one model. So let's take a look at the example. Okay, so you can see we have the sales data. And obviously from sales data, can you see some kind of seasonalities? Yes? No? No. You can see the look at it here, right? If it's greater than 1, it will be higher than average season. So what we can do? So obviously we can see April, May, June, July, and even August. The data value are higher than the other months. That's a seasonality. In the summertime, the sales are strong, and other times the sales are slow. That's all seasonality. So what we can do is first we can develop the average demand for the past 2 years for each season, for each month. So we can get this column. Is that clear? Yeah. And then we can compute. We add all the data points. See, or you can add all the data points for the past 2 years, divided by 24. You will get 94. 94. What's the concept of 94? Average monthly demand. Right? We lump everything together. Take advantage of all the data we have. So on average, there's 94. But of course, some months the data is greater than 94. Other months is less than 94. So that's how we created the seasonal index. So we have the average two-year data divided by the monthly data, the average monthly data. And then this is the seasonal index. And remember, if the seasonal index is less than 1, that means what? That month's number is less than the average, right? Less than the average. If it's greater than 1, it's higher than the average. So the seasonal index is the average 2-year demand divided by the average monthly demand. So now once we have the seasonal, so for each particular month we have the index, right? So for example, for June, this is the number, right? 1.22. So now what we can do is, so if you ask to predict the 30-year data, for the 30-year data, the only thing I tell you is the total demand for the year is 1,200. So you do the calculation 12 months. So each month basically is 100. And then so then if I use the seasonal index, so that for each month is 100, then it times for the seasonal index. So that's a distribution. That's a distribution. So those are the seasonal data. You see the adjustment for the summertime.
Can you go back one slide, please?
Uh-huh.
I have a question. Why is it divided by 12 months when you added 2 years? That's 24.
Oh no, this is 1122 is you add those. Hold on.
No,
You
the
know,
1128, you said add up all of it for 2 years.
Yeah,
And
yeah.
then divide it by the number of months, but that's 12 months. It would be 24 months.
So in this case, you add those together, yeah? Or you can add those together divided by 24.
Okay.
You add this together divided by 12.
Okay.
Because this already is the average.
Okay, okay.
The whole idea is for
Somebody else
we
has
take
that
we use all the data. You basically you find the average monthly demand is 94. You can add all those together divided by 24 months. You will find it's equal to 94.
Okay. Thank you. I'm not doing
But sometimes for seasonal index with a trend. So we have seasonality, and also there's a trend. And then we have some difficulty, right? The changes could be due to trend, season, or a random variation. So if that's the case, one technique we can use is called a CMA, centered moving average. Centered moving average. So the centered moving average basically is trying to take care of the trend. Take a trend. And if I show you the data, yeah, show you the, hold on. Let me see, show you the data first. So this, I have the quarter data for the past 4 years, 3 years. And you can see the average for quarter 1, quarter 2, quarter 3, quarter 4, yeah, the average. And also for year 1, year 2, year 3. Can you see the seasonality? Yes, through where? You see the seasonal pattern. The quarter 1 is usually quarter 3, quarter 4, yeah? The numbers are high. Quarter 1, quarter 2 relatively low, especially quarter 1. And also you see the trend over time, year 1, year 2, year 3. So we have the presence of both seasonal variation and the trend. So that's why we have a difficult assignment. So the step is so we need to compute. It's called centered moving average. Centered moving average. Now, what is centered moving average? Centered moving average is. Do I have an example here? Oh, the centered moving average is we use 1.5 quarters before. So if we, let's say we're interested in quarter 3, so we use 1.5 quarters before quarter 3 and 1.45 quarters after quarter 3. So in other words, so if we are interested in quarter 3, let's say this, we have quarter 1, year 1, quarter 2, quarter 3, quarter 4, quarter 5, no, not, sorry, there's no quarter 5. Second year, right? And then again with quarter 1, quarter 2, quarter 3, quarter 4, yeah? Correct. So in this case, we will have to start from with this quarter. Because we needed to what? Have 1.5 quarters. Now what is 1.5 before? So which will include what? This quarter and 1.5 of this quarter. This is 0.5, this is 1. Now of course we will include this one, yeah? Then for quarter 3, we're also 1.5 here, right? So that's, this is 1, this is 1. Then we take the average divided by 4. That's the center. See, the idea is we're trying to cover more quarters so we can basically smooth out the trend, take care of the trend. That's one. And once we have it's called a CMA, Center Moving Average. This is also moving average. Then we move to quarter 4. We have to include what? Quarter 3,
And then 25.
and then half for quarter 2, quarter 1, and half of quarter 2. So once we have the CMA, and then we can find the seasonal index. So how to find the seasonal index? The sales in a particular quarter is divided by the centered moving average. And once we have the seasonal index, and then we can deseasonalize the data. Okay, so let's take a look at it here. Yeah. So you have to organize the data into a column, in a column. But it would be better if you can indicate 1, 2, 3 year, 1, 2, 3, 4 quarters. This afternoon I tried not to use in the quarters, but I had a hard time to know like which cell is which. So eventually I have to insert one more column for the quarters. So now the data is clear. It's from the first quarter, first year, all the way to the fourth quarter of the third year. Okay. So the CMA for this year, it's clear. This number, how do you get this number? Half of this number, plus this number, of course plus this number, plus this number, and plus half this number. Divided by 4, you get this out of it. And then you see that this quarter, and then we can develop the seasonal ratio. Seasonal ratio. See, for third quarter, we have the data value for what? How many data values do we have? 2, yeah? 2 data values. So then if we use all the information we have, so for quarter 3, we have 2 indexes. Yeah? We have the 2 seasonal index. We take the average of both. So this gives us what? This gives us the seasonal index. This gives us the seasonal index. And once we have the seasonal index, and we can, see those are the seasonal index. It repeats, yeah? Quarter 1 always use 0.85. Quarter 2 is 0.96. Quarter 3, quarter 4. Then it repeats. It repeats. So we can deseasonalize the data. So this is the sales of seasonal data, but we have a seasonal index. So this number divided by this number, those are the deseasonalized data. Once we have deseasonalized data, can we again remember the trend projection? We can use the trend projection to project the fourth year, the 4 quarters data. And once we have the fourth year's quarterly data, and again we can use the seasonal index to find the final projected data. And I think we probably needed to do one complete example here to. That's the homework assignment for. What time do you have? Let's take a 5 minutes break. I can also stop the video. Yeah, hold on.